Hey guys, thanks for watching my YouTube video here. I hope you're ready for some more magnificent math with Mech or McIntyre. Forgot to fix that. So embarrassing. Today I just wanted to talk about similar polygons, what they are, how you know if you have them, how to solve for a side, all that fun stuff awaits. So here's the definition. If you want to pause and copy it down, feel free. Similar polygons exist if their corresponding angles are congruent and their corresponding side lengths are proportional. Alright, so if I'm asking you about similar polygons, those are the two things you need to check. Are their angles the same? Are their side lengths proportional? Okay, the symbol for similarity is just that little squiggle right there, which you should recognize because the symbol for congruence had that same squiggle, but included the equal sign because the congruent means the exact same. Alright, so here's my first example. So again, if you want to pause and just copy down the information, I know you don't have these numbers or letters written down, but I just have an example here of two polygons that are similar, and here the statement, this similarity statement says ABCD is similar to QRST. So that means that angle A and angle Q are the same. Angle B and angle R, the same. Angle C and I forgot the angle. Angle S, the same. Angle D and angle T, the same. Okay? That's what that means. Also, it means that our side lengths are proportional. So I have 16 over 20 because those sides correspond. That is the same as 8 over 10. Those side lengths correspond, and then you guessed it, 12 over 15. Those side lengths correspond. Now you'll notice 16 is definitely not the same as 20. Am I right? But when I make my fraction or my ratio and then I simplify, I get the same thing. Okay, that's proportional. All right, so when you simplify your fraction, you get the same exact fraction, which you should have seen with your triangles that you did the discovery work on. When you simplify the fractions, you got the same thing, and that number is your scale factor, okay? So you have to simplify your fractions, and that will give you your scale factor. So that's the ratio between the corresponding sides. Okay? All right, let's flip. Boom, boom. So here we go. Second example. Again, if you want to pause, jot this down. Could be helpful. Now the instructions say, determine whether the triangles are similar. If they are, then you need to write a similarity statement and find the scale factor of figure B to figure A. So like I said about 3 minutes ago, you could rewind and listen if you wanted to. When you're trying to figure out if you have two shapes that are similar, you have to check two things. The first thing you got to check, are my corresponding angles congruent? Well, let's look. H and K. Hey, they're congruent because they both have one arc. J and L. They're congruent because they both have 3 arcs on their angles, meaning they're congruent. Same with G and M. So their angles are congruent. Awesome. Now we have to check the corresponding sides. So I want to know if 12 over 16 is the same as 15 over 20 is the same as 9 over 12. So I need to set up my ratios, and then I'm going to simplify, right? Because I'm like, well, 12 doesn't equal 15, or 12 doesn't, you know. Okay, well, let's see if they all simplify to the same thing. So this is 3 over 4. This is 3 over 4. This is 3 over 4. So winner, winner, chicken dinner. They are similar. Now it says, if they are similar, write a similarity statement. Well, this is very similar to a congruence statement. So I'm saying triangle HJG is similar to, not congruent, triangle, watch your order, LM. Okay, so there's my similarity statement. Now it says scale factor of figure B to figure A. This is a really small detail, but it matters a lot. Because if I'm asking for the scale factor, how do you know if I want 3 over 4 or 4 over 3. You know, who's to say you didn't set up your fractions as 16 over 12? Well, whichever one comes first, like when I'm asking for it, asking for the scale factor, that number is going to go on top. So if I want the scale factor of figure B to figure A, that's going to be 16 over 12 or 4/3. That's my scale factor, okay? If you write it as a decimal, like 1.3 repeating, that's also fine, okay? But I'll tell you right now on the test, I'm going to ask for this several times, and if you're not paying attention to which one comes first, you're going to give me the wrong thing. I don't know who's going to do it, but one of you. If anyone wants to volunteer, let me know. Okay, so that's how we determine if polygons are similar, okay? Now, our third example. Boop, boop. Now that should say triangle, similar, okay. So triangle RST is similar to triangle GHI. Find the value of x. I didn't even fill in the letters for you, good grief. But here we go. We have two similar triangles, and now we're going to use the fact that we know that they're similar to set up a proportion and solve for x. Okay? Now there are several different fractions we could set up, and it's not, what am I saying? There's not just one fraction that will work, okay? But however you set up your first fraction is how you need to finish the second fraction. So for example, if I set up 15 over 10, because they're corresponding sides, so if I do big over small, I have to finish my fraction or my proportion with big over small. I have to finish with 9 over x. I couldn't flip that around and do x over 9, okay? Or, you know, if I started my proportion with a 9 over x, if I did big over small, I'd have to finish it with 15 over 10. That was a bad second example because it was just the same thing. Or here's another way I could set it up, and I don't want to confuse you, so if you're like, all right, I got it, then just, you know, pause the video, solve for x, and then make sure that you're right. But you could also set up 10 over x. So now I'm taking my two sides from the smaller triangle, and I went this side over this side. I could finish that with 15 over 9. Okay, so a couple different ways you can set up your proportion. You should get the same thing after you cross multiply and solve for x. You get x equals 6. All right, so there you go. Once you know that you have polygons that are similar, then you know their corresponding side lengths are proportional. Then you can set up your proportions and solve, and that's what you'll be doing with the MathLib activity following these notes. Thanks for watching. Hope you learned something. Have a great day.